Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And the title is Simple as AB, but not ABC. ABC, it's as easy as 1, 2, 3, as simple as do, re, mi. So there's no simple as for that song. So that's a Jackson 5 song. Um, but it's basically simple as do re mi, not ABC. So okay, that's fair enough. We don't have an A B and a C here, and this is by Nicholas Duhale. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Clues outside the grid indicate the sum of the first x digits, where x is the first digit seen. So, for example, if we had 6 here, this A would have to be the sum of the first 6 digits seen here. And A and B represents two numbers to be determined by the solver. So again, these are numbers, not digits. So they could be two-digit numbers. Keep that in mind. Any three adjacent digits along a teal modular line have different residues. That's interesting. I think that might be a translation error. Unless other countries' math teach it differently. Usually it's called remainders. Usually it's different remainders modulo 3. That is one digit from 1, 4, 7, which is 1 modulo 3, one from 2, 5, and 8, which is 2 modulo 3, and one from 3, 6, 9, which is 0 modulo 3. I don't know if other countries call them residues. Maybe that's a term that they specifically use, but usually the way we've been taught is that they were called remainders modulo 3, which is when you divide by 3, essentially, what is the remainder once you divide part of it evenly. So, for example, 8 divided by 3, gives you 2 plus some remainder, right? And that remainder would be 2. So that's why it's considered 2 modulo 3. Anyways, those are all the rules. Actually, let's use an example. So say we had 6 there, we could have 7 here, and then 5 there. And this would be valid, because, or at least along this, and then this would be like 3 or 9. So this would be valid because in this set of 3 digits, we have one digit, which is 0 mod 3, which is the 3, one that's 1 mod 3, which is a 7, and one that's 2 mod 3, which is the 5. In this set of 3 unique adjacent digits, we have one digit that is 0 mod 3, the 6, one that's 1 mod 3, the 7, and one that is 2 mod 3, which is the 5. So that's an example of how modulos work. Modular lines, I should say, work. Anyways, again, A and B represents two distinct numbers. Actually, I guess they don't have to be different. I'm assuming they are, but I'm not gonna make that assumption I'm not assuming they are, but I'm thinking that they're probably going to be different numbers. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, these are the same modular set because every 3 digits on a modular line have to be from the same set. Because since every 3 digits, adjacent digits on a teal line have to have one of each of the distinct sets, the one that you're losing has to be exactly the same as the one that you're gaining if you have greater than 3 digits on a teal line. So these have to be the same modulo set. Well, what are that means they must either be 1 and 4, 4 and 7, 1 and 7, 2, 5, 5, 8, or 2, 8, or 3, 6, 6, 9, or 3 and 9. Well, 1 we can throw away immediately because 1 is never going to have the same sum as another set of digits with like 4, right? Or 7. 4 digits is not, obviously 1 digit only adds up to 1. So that's there. 9 is the same way. 9 is never going to add up to the same sum as 3 or 6 because 9 is guaranteed to add up to 45 and 3 or 6 are guaranteed to be less than 45. So we cannot have 9 or 1 here. I don't think we can have 2. 2 adds up to at most 11, and 5 adds up to at least 15. So 2 doesn't work either. What about 3? 3 adds up to at most 20. And 6 adds up to at least 21. So 3 doesn't work. So for these to be the same modulo set, they have to be... It can be 4 and 7, I think does work. 4 could add up to 28, and 7 could add up to 28. It cannot be 3 and 6 or 6 and 9, so therefore it's 5 or 8. So if it's 4 and 7, 4 can add up to 28 at minimum. Has to add up, sorry, 4 can add up to 28 at maximum. And 7 adds up to 28 exactly. So then A would be 28. If it's 5 and 8, oh, that doesn't work. 5 and 8 add up to... 5 adds up to at most 35. 5, 6, 7, 8, 9. And 8 adds up to at minimum 36, which is... So therefore it cannot be 5 and 8. Therefore, this has to be a 4-7 pair. They must add up to 28 then. So A always adds up to 28. That means it has to be, these digits have to be to add up to 28 for the x sums. These are known as x sums. Must be 4 through 7. Okay. What about B? So the only relationship we have with B that we really know anything about is this column here. Column 4. So if we have 7 here, so say we had 7 here, that would guarantee these have to be 1 through 6 to add up to 28. And this would be 4, obviously, adding up to 7, 8, and 9. But then this would have to be an 8 and 9 pair here. Obviously, so B cannot be 9, because that would mean that B has to be 45, and all of these B's would have to have a 9 as the X part of the X sum. But it doesn't work for 8 either, I don't think. Okay, so if this is 8, that means the sum is 45 minus 8. Sorry, 45 minus 7, because we don't include the 7. So then that's 38. But to add up to 38, is that possible? So then this would be, okay, so then we have 8, 9 here. To add up to 38, you could be missing 7 or 6. So potentially that could be possible. So then we would have essentially 6, 7 here. This would be 6, 7. That would be 6, 7 as a pair, so that would eliminate 6 and 7 in the rest of the row. This could not be 4 or 5. So to add up to 38, we'd have 6 or 7 as a pair, right? 6 is the minimum. Because you could be missing 1, 2, and 4. Anyways, this would be 6, 7 as a pair, which would eliminate 6, 7 in the rest of the row. So this could not be 4 adding up because 4 is guaranteed to add up to 28. It has to be with 5, 6, 4, with 7, 8, and 9. So then this would have to be 5, which would make that 4. So this would have to be 7, 8, and 9 here. 5 digits. The first 5 digits must add up to then 28 in that instance. 5, 6, and 7 would have to be, it adds up to 18. So the remaining 2 digits must add up to 28 minus 18, which is 10. So then this can't be 9 because of a 7, 8, 9 triplet in the column. And this can't be, we can't have 4, 6, or 3, 7, or 2, 8 here. So this is 1, 9. So this would have to be 9, and that's 1. So possibly, okay, so that is possible. Remaining digits of row, so first 5 digits, 5, 6, 7 is 18, plus 1 and 9 is 28. Remaining digits of column 7, we have 2, 3, 5, and 6. Obviously no 5s there. So if this is 6, it would have to be 1, 2, 4 here. If this is 6 here, this would have to be 1, 2, 4 for the digits missing to add up to 38. But this can't be 1, 2, 4. So therefore, this would have to be 6. This would be 7. This would be missing 1, 2, and 4 here. No 4 here. That eliminates 1, 2, and 4 in the rest of the box. Oh, we'd have 2 9s here, and we'd have a contradiction. There we go. So that proves that this can never be 7 for A in column 4. So this has to be 4 here, which makes that 7. Therefore, this is 7, 8, 9. That means the rest of this has to be 1 through 6 here to add up to 28. This is 4 through 9 to add up to 28 there. So this is 1, 2, 3, 5, and 6. B cannot be 1 for the same reasoning, because then all of these would be 1 for these B's. This has to be an 8 and 9 pair there. Okay. 2. If you have 2 here, that only adds up to 8 at most. And we can't have 3 digits here that add up, that would sum up to 8 for that many digits, right? 2 and 3 are the only ones that add up to 8. So this cannot be 2. 3 could work. Could 6 work? Quite possibly, yes. Oh, interesting. These two sum up to the same sum. Huh. Interesting. Is that possible if they overlap? I don't know if it is. This is the same modulo set as that. Oh, we also have this adds up to 28. Oh. Interesting. I guess you can if you overlap. So yeah, this is also probably very interesting for that. So we have 28. That means 45. 28 plus 28 is 56. So we have 11 overlapping in the middle, which means it has to be it cannot be 4 and 7 because if we have 4 and 4 requires these to be 7, 8, 9, and that's not going to happen. And this would be 4 would have to require that to be 7, 8, 9. So this cannot be 4 and 7. It has to be 5, 6 as a pair, which eliminates 5, 6 in the rest of the row. So one of these is going to be 5, and then the other one's going to be 6. And the overlap has to add up to 11. Certainly possible. Okay, so overlapping does work. 28 plus 28. Okay. What you know is that these cannot add up to 10. Oh, this is 5 and 6. And 5 and 6. If this is 5, this must be 2 or 8. Whoa, that's weird. So that would mean 6 would be 3 or 9. If this is 5, this is 2 or 8. So you have 3 or 9 there. Well, obviously 9 doesn't work. Because then B would be 45 both ways, and that wouldn't work here. Can it be 8 both ways? Well, the other one must add up to 3 digits. So 8 is never going to add up to what 3 digits add up to. So it must be 2 and 3 here. Interesting. That eliminates 2 and 3 in the rest of the row. So this can't... 5, 2 is at most going to add up to 11. So therefore, this must add up to 11 here for the B. So therefore, this is 3. There's no way it's going to be less than 3. We have to have 1 out of 5 or 6 here. So it could be 1, 5 here. And this, so this is guaranteed. It can't be both 5 and 6. That adds up to 14. It has to be 10. Since 2 and 3 add up to there, we can't add up to 11 because you can't have 4 digits adding up to 11. We need to have 3 different digits here adding up to 11. So then this has to be a 2-4 pair here. That eliminates 4 in the rest of the row. And 2 can only add up to at most 11. And 4 adds up to a minimum of 10. And 4 can never add up to 11, including the 4. So therefore, this can't be 4. Well, it could be 4 if it's 2. So this must add up to 10. It's either 1, 6, or it's 2, 5 here. And this cannot be 1 or 2 here. It's 5 or 6. So if we have 3 here, it adds up to 10 without the 2. So 10 minus 3 is 7. We don't have 3, 4 available. We don't have 2, 5 available, so it's 1, 6. So this is either 1, 6, or 8, and this is 1, 6, or 8 here. And we have a guaranteed 1, 6 is one of these 3 digits. And then the other one would be 8. So this cannot, the rest of row row 2 outside of these cells cannot have 1, 2, 3, 1, 6, or 8. Interesting. Well, this can't have 4 here because of 4 in the box. No 1, 2, 3, 4, 6, or 8. So we have 5, 7, 9 as possibilities. This is then becomes a 5, 7, 9 triplet, which eliminates 5, 7, and 9 in the rest of the row. So either this is 1, 6, or this is 4 here. And this 5, 7, 9 triplet eliminates 5, 7, 9 in the rest of the box. So this can't be 7 or 9. It's 8. That means, interesting, remaining digits in box 2 have to be 1, 2, 3, and 6. Well, 1 cannot be on this modular line. We need a 2 mod 3, and the only 2 mod 3 left is a 2, so this can't be 2. So this is 1 guaranteed here, and 2 guaranteed here. That eliminates 1 there. Okay. So this cannot be 2, because that would force 2 and 8 to be there. So this must be 4 here. This is 2 here. 2 and 8 add up to 10. That means this can't be 8. That's 9. That's 8. 4 must be with 1, 2, and 3 to add up to 10. That eliminates 4 here, and 2 can't be here. So this can't be 2 and 5. This is 1, 6 as a pair to add up to 10. That makes this not 6, so it's 5. That makes this not 1, so that's 2. That eliminates 2 there. 8 eliminates 8 here. 2 and 8. 2 means this 2 can't be 2, so where's 2 on this modular line? It has to be there. Okay. Remaining digits of column 8 are 5 through 9. And this can't be 7 because of 7 in the box. So if this is 3, this is 6, which makes that 1. If this is 2, that's 8, which makes that 4. Okay. So 7 has to be one of these 2. Okay. A here adds up to 28. Remaining digits of box 8, we have 5, 7, 8, and 9. No, not 5, 7, 8, 9. 4, 5, 7, 9. There we go. So this can't be 4 here. This can't be 9 because of 4 and 9 in the box. We have a 4, 5, 7, 9 quadruplet in column 6, which eliminates 4, 5, 7, 9 in the rest of the column. So that leaves us with 1, 3, 6, and 8. Interesting. That means 4 is guaranteed to be one of these 3 digits here, so this can't be 4. Can this be 5? Adding up to 28. 5, 2, and 8. Okay, so we have 2, 8, and 4 already. That's 14. So 28 minus 14 is 14. We could have 5 and 9 there. That is possible. What about 6? 6, 5, and 3 works. We have a guaranteed 1 in one of these cells here. That's interesting. Can this be 7 is the other question. Actually, one thing we do know. Where is this 5, 6 in box 9? Cannot be here. Can't be any of these digits because they can't be 5 or 6. So it has to be this digit here. So this is guaranteed to be 5 or 6. So this is the same digit as that. Therefore, it has to be one of those 3. Can we be 7? 7 would mean the remaining 2 digits have to add up to 45 minus 28, which is 17. But that requires 8 and 9 there, and that's not possible. So this cannot be 7. So this is 5. We have a 5, 6, 5, 6 pair in column 9. So the rest of the column cannot be 5 or 6. We have to have a 7 here, and this is 1, 2, or 3 here. So 7 is guaranteed to be here. If we have 5 here, that makes this 9. If this is 6 here, this is 14 already. We have to have 5 here. So we're guaranteed one of these two is a 5. That eliminates 5 from being here. Not sure where this blue 5, 6 is. 5 eliminates 5 here. Remaining digits of column 5. 1, 3, 4, 6, 7, and 9. Well, 1 can't be here because either these two digits add up to 11 or these two digits add up to 11. If these two digits add up to 11, it's 2 and 9. What about these two? You can't have 4. 4 and 7 add up to 11, but this can't be 7. And you can't have 7 here. You can't have 6 because of the 5, 6 pair in the row. So this would be 3 and 8 if that were the case there. This can't be 5 or 6 because of 5, 6 pair in the row. So it's either 2, 9 here in this, or this is 3 and 8. I'm not sure which. Okay. 7 would require 7 would require these to be 8 and 9, which is possible. 6. Can this be 1? Actually, that's a good question. What happens if this is 6? If this is 6, that makes this 5, which makes this 6, which makes that 5. Therefore, this must be 2 to be the same modular set as the 5. That would be 3 there. And therefore, this would be 8. So either way, this is guaranteed to be 8. Ah, interesting. So, because if this is 7, therefore it has to have 8 and 9 here, and this would be then 8, and that would be 9. So this is guaranteed to be 8, which makes that 6, which means this is 2 and 8 here. That's 3, 6, and 1 there. That makes that a 4 there. 2 means this has to be 5. That's 6. So these 5 add up to 28. So do these 6. So these are the overlap, which means it must add up to 11. So that means it's 2 and 9 there. That eliminates 9 in the rest of the column. These add up to 28. So we have what? 2, that's 11 plus 5. 11 plus 5 is 16. No. 6, yes, 16. 11 plus 5 is 16. 28 minus 16 is 12. So these two digits must add up to 12 without 5, which means no 5, 7, and without 9, which means no 3, 9. So it's 4 and 8. This can't be 4 because of 4 in the column, so this is 8 here, which makes this 4 there. That 8 eliminates 8 here, so it's 7. This can't be 8 or 4. It's a 1, 3 pair. So this must add up to 28. 1 and 9 is 10. 3 and 7 is 10. 2 and 6 is 8. So that does add up to 28. 6 eliminates 6 here, so it's 5. So this is 5. That means these must add up to 28. So 5, 4. So 2 and 8 is 10. 14. So this must be 5 and 9. That eliminates 9 in the rest of column 6. So where is the 9 in row 2? It has to be here. So that's 9, which makes this 7. That eliminates 7 in the rest of the box. That eliminates 7 here. Well, we already knew that. 6 eliminates 6 in the rest of the column and box. No 3 here. 1 eliminates 1 here, so that's 3, which makes that 1. That eliminates 1 and 3 in the rest of the row. This is 6, so this must be 6 there. That eliminates 6 here, so it's 1 and 6. 1 eliminates 1 in the rest of the row. Okay, that eliminates 6 in the rest of the column. This is 2 and 5. We need a 2 modulo 3 and a 1 modulo 3 here. Okay. This is 5. Can we have... Okay, so if we have 6 here, remaining digits in row 9 are 1, 6, and 7. Okay. Remaining digits in column 9, we have 1, 2, hold up. 3 eliminates 3 here. I guess we still have 1, 2. We have 1, 2, 4, no 7, 8, and 9. Okay. 1 can't be here because of 1 in the box. Don't really have any more information here. 1 eliminates 1 in the rest of the box here, and 1 in the row. So this can't, where's 1 in box 2? It has to be there. 3 eliminates 3 in the rest of the box. This adds up to 10 here. So obviously no 1. 4 is not going to work because 4 needs 1, 2, 3, 5, or 1, 2, 3 with that. And these can't be 1, 2, or 3. So this is 2. 2 and 8 there. 2 eliminates 2 in the rest of the column. So this is 7. That's 1. That eliminates 2 in the rest of the box. So this is 1, 4, and 5. That means this can't be 4, 5. It's 2. No more 2 here. We have a 2 mod 3, a 0 mod 3. That makes this a 1 mod 3. It cannot be 1 or 7. So this is 4. That makes this a 9 here. 4 eliminates 4 here. Where is the 4 in box 5? It has to be there. 8 eliminates 8 there. We have a 3, 6 pair in box 5, which eliminates 3 and 6 in the rest of the box. So this can't be 3 or 6. It's 8. 1 eliminates 1 here. It's 2, 3 as a pair. This can't be 2, 4, or 9. It's 8. That eliminates 8 in the rest of the box. Okay. So all the x sums, I believe, are done. Oh, no, except for A here. So this adds up to 28. This adds up to 28. 28 here, 10, 10, 8. 28 here, 10, and 18. 28 here, 10, 14, and another 14 is 28. We have 10 here, 10 here, 10 here, 10 here, 10 here, 10 here. So it's really this one. Okay, remaining digits. Remaining digits of row 1, we have 1, 3, 6, 5, and 9. Okay. Remaining digits of row 3, we have 3, 5, 6, 7, 9. Okay. This can't be 5. That's 2 modulo. Wait, we have 5 in the column. Okay. Where are 4 and 8 in column 1? Can't be here because of 4 and 8 in the box. Can't be here because of 4 and 8 in the row, so they have to both be here. 8 eliminates 8 in the rest of this row, so this can't be 8. It's 4, which makes that 8. That means this can't be 4 here. Where's 4 in box 8? It has to be here. Okay. Good to know. Remaining digits of box 7. We have 2, 3, 5, and 9. No 9s here because of 9s in the row. We have a 2, 3, 5 triplet in row 8, which eliminates 2, 3, 5 in the rest of the row, so this can't be 5. That's 7, which makes this 5. That eliminates 5 there, so it's 7 and 5 there. Okay. 5 cannot be here because of 5 in the row. So we're guaranteed a 9 here. We're guaranteed a 5 there. Remaining digits of row 4. We have 1, 3, 6, and 9. Remaining digits of row 6. We have 2, 3, 6, and 7. Okay. No 2 here because of 2 in the column. Okay. Can this be 6? That means the remaining 3 digits. 7 could work as long as it's these two add up to 17, which would mean 8 and 9. With 6, again, this would have to add up to 17. So these 2 digits would have to be 17. So either this is 9, or there's going to be a 3-6 pair. So this cannot be 1 or 5 there. So this is guaranteed to be 3, 6, or 9. So either this is 9 or this is a 3-6 pair. Which doesn't work because this would require the 6 to be there. So this cannot be 6, therefore this is 7. So that's 7, so this must be the digits 1 through 7 here, adding up to 28. That makes this a 9 there, so this can't be 9, that's 5, which makes that 9. That eliminates 5 and 9 in the rest of the row and box here. No 9 here, no 9 here. Seven eliminates 7 here and 7 here. Interesting. Okay. We need a 1 somewhere in column 2. So it's not going to be here, can't be here, can't be here, so it has to be there. So this is 1, which means this cannot be 1, and this can't be 1. This is a guaranteed 0 mod 3 here. So we need a 1 mod 3 here. So that's 7, which eliminates 7 in the rest of the row. Where is 7 in column 2? Well, this can't be 7 here because of 7's in the columns. Where's 7 in row 6? So it has to be here. Um, hmm. Okay. We have a 1, 3, 6 triplet in column 1, which eliminates 1, 3, 6 on the rest of the column. So this can't be 1, 3, or 6. It's 9. That eliminates 9 from being there. We have a 3, 6 pair in box 4, which eliminates 3, 6 in the rest of the box. So this can't be 3 or 6. It's 2. That eliminates 2 there. So it's 3, which makes that 2, which makes that 3. This can't be 2 or 3. It's 5. This can't be 3 or 5. It's 2. This can't be 2 or 3. It's 9. Um, okay. We have a 1, 3, 6 triplet in column 3, which eliminates 1, 3, 6 in the rest of the column. And this is 3, 5, which eliminates 3, 5 here, so that's 6. That means this can't be 6. It's 1, 3 as a pair. 6 eliminates 6 here, so that's 3, which makes that 6. That eliminates 6 there, so that's 3, which makes that 6. Which eliminates 6 there, that's 3. 6 eliminates 6 here, so it's 1 and 6. This can't be 3 or 6, it's 5. 1 eliminates 1 here, so it's 3, which makes that 1, and therefore this is 6. And that's a solution. Yeah, fairly straightforward. The modular lines definitely restricted things a lot, and it was interesting how the x sums related to that. Yeah, it seems about challenging level to me. Flowed very well throughout. It was a very interesting how the restrictions restricted things. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.